English dictionary to capture as much of the handwriting as possible and place a few restrictions on the writer and the student. We had to find an algorithm to search here. We had the Viterbi algorithm, which we couldn't use, the classic algorithm, because the dictionary was very large and classifying time would have exploded, especially on the epoch. So we implemented our new and fast search technique, which was inspired by the N system, which is a negative system. I don't know what I pressed on the one.
While they are focusing on the PowerPoint, I'll ask my colleague Alex to present to you the market overview so that we don't lose any time.
Thank you, Monica. So let's talk about where we have our references from our statistics. We only use each country, Brazil, China, India, Russia, Romania. Official government sites for the Ministry of Education, we have data about the school and the number of schools that funding. And we also use these to calculate how much of their budget for one student in a year would have to go to use our project. And in India, the percentage was a bit more, it was 40%, but in the rest of the countries it was below 10%. In Brazil, for example, it was 3. The cost of the system has been computed using only retail product prices. So we expect a drop from $20 to $64 to $15 or $16 in our mass production version. Continuing, our system is focused on emerging economies that they already have the infrastructure required and the financial power to implement this, but do not afford to use more expensive solutions such as a tablet PC or a computer for each student. Our target group is therefore institutions, primary schools, secondary schools, high schools, even colleges in this country. You can see here the figures we have in our function. And we focus in the lower grade on helping the child organize his information, help the teacher in having better access to his materials, and even allow the parents to supervise the performance of their offspring and help them meet it. For the higher grade, we focus on helping the teacher grade papers a lot faster, allow the students not to lose their papers and preventing fraud. Also, we have the research alternatives of school-level learning systems. There are e-learning such as www.course.ts.path.gov, which is a site where students can go and upload, download files, check up their grades, and complete assignments, or an e-class, AEL, which is a system which provides the teacher with a server from which he can download materials and use them straight in class. Another important mention would be the classmate, which could be very easily integrated with our system, and the project is used in many countries, including our own. The idea is we can do this because of the modularity of our project and the fact that the classroom we need also the operating system. The e-books. Let's return to the e-books and the question of mathematics. Why do we use it? We use an embedded system for its processing power. No PC could handle 20 or more online synthetic recognition inputs at once. So that is why we use the e-books to a fast and reliable solution, and also a very robust one, to improve the education for all.
Going back to the video, we are sorry for the inconvenience. I don't know if it went wrong. So I will let you explain further.
Well, we were on the recognition rate. We have 3 classes of recognition rates. We have the writers that participate in the training gathering phase, which includes me, for example, and the rates are high, are even exceed 90%. We have writers with familiar writing styles in the training phase, which are between 70% and 90%. And of course, the bad case, the worst case, when the writing isn't familiar with the writing style we use in the training gathering. All these cases were present in the demo we did a few days ago. This is a consequence of the low amount of training data we obtained. We obtained about 6,000 words in our writing festival, Write Talk 2007. We would have needed at least 40,000 words for a more robust parameter estimation for the model. Let me tell you something about the development process. We used the HTK framework for training. It's actually a library available on the internet. It is a framework for speech recognition systems. The development process went through 3 iterative stages. First, we built a character recognizer. Afterwards, we built a word recognizer. And the most challenging part was to build a continuous handwriting recognizer. This is the research, some of the most important titles we use in our research. The first one is an introduction to the statistical models we use, hidden Markov models. The second one I already mentioned is the search technique for classifying threads. And of course the HTK book, a tutorial book, which we use for the training phase. The most challenging part of this research phase was that the related work was mostly focused on isolated character recognition and word recognition, so we had to extend it to continuous handwriting recognition. So, as a conclusion, through the use of extensive research and efficient algorithms, we made the perfect system for handwriting recognition system. We have the answer evaluation tier, which has tools to aid the teacher in monitoring the class in real time, and some answer evaluation, automatic answer evaluation. We have the quiz evaluation, which is rather easy to do, and the automatic evaluation of elaborate answers through latent semantic analysis. About the latent semantic analysis,